Thank you, Sebastian, and it's really good to be here. Yes, I've always enjoyed my visits to Germany for these conferences and speaking here and meeting folk here. So today, I imagine some of you probably will groan about the fact that it's yet another talk about AI. I think that AI is actually an opportunity for a lot of enterprise developers, and I think it's a very exciting opportunity. I think it's a particularly exciting opportunity for Java developers. Firstly, we do have to talk about it. It is the elephant in the room. It's not just hype, it's not going away. So for all of us, it will have a big impact on our careers, potentially a threat, but also an opportunity. So, I think it really has, for all of us, to be top of mind in terms of what we're thinking about and how we want to move forward professionally. There are some things presently that work and some things that don't work with Gen AI. This is one of the paradoxes that I think makes it quite fascinating. That, you'll ask an assistant, or Claude, or ChatGPT, or a coding agent to do one thing that might be quite hard. You think it's hard? Does it really easily. You ask it to do something else and it totally messes it up. So there's a great deal of inconsistency. And this is something that we have to deal with in many ways. So, some of the things that work tend to fall under the personal assistance use case. So for example, you go ask ChatGPT, you go ask Claude a question, very often the answers are really good. Occasionally they're wrong. Maybe 10% of the time it's somewhat wrong, maybe 2% of the time it's totally wrong. But it still doesn't really matter because 90% of the time or more, you're going to get a really great answer and you're going to move faster. And I would say the personal assistance use case extends to coding agents. That's just another pretty specialized form of that. And generally it works really, really well. How many people here are using some form of coding agent in their daily work? Wow, that's really, really good. Because that certainly is potentially an immense productivity boost. But again, we're all professional software developers. It's not about replacing us, it's about augmenting us. You get suggestions that are not right. There's this wonderful thing called Git. It's miraculous. It's like something bad happened, you revert. Never existed. There's no record of that bad thing ever happening. This is really, really great if you have that ability to experiment and roll back. But obviously, business processes are not the same. You can't roll back something you put in front of a customer. Like, for example, Air Canada tried rolling back something they put in front of a customer. A chatbot a couple of years ago gave a customer a ridiculously low quote. Air Canada, after the customer had accepted that quote and bought the ticket, tried to deny the customer the deal, and it ended up going to court and Air Canada lost. It was not as easy as just reverting in Git. So for the personal assistant use case, powerful but unpredictable is often fine. For example, if you consider Claude Code, the key innovation of Claude Code was the notion of the to-do list, where it creates a list of tasks, it updates those tasks as it goes through, and it's autonomous, right? It's doing this with the model really taking control of the workflow. Most of the time it really works great, but it doesn't really work to automate business processes because it's just too unpredictable. So it's perfectly fine for what it does, but you can't easily generalize it. An example of, powerful but unpredictable. I asked Nano Banana to create an illustration for the previous points. On the left, we have what Nano Banana thinks of as the personal assistance use case. I don't know about you, I'm kind of a little scared by that. I think we can safely agree it didn't capture what I wanted to say, but also, I don't know, there's something else going on there. So it's not that surprising that while personal productivity boosts are undeniable and clearly many of us are enjoying that. Gen AI has not translated at all well to enterprise. Like, you can debate whether or not these individual studies are valid, like the 95% failure from MIT seems a little high. But there are enough data points out there that it's very clear that enterprises, by and large, are not getting the results they want from Gen AI. That is both a problem and an opportunity. It's a severe problem for enterprise because obviously they would love to reap the rewards of this powerful new technology. But it's actually an opportunity for us because we're the people who need to make this work. And I believe it can be made to work. So why do Gen AI projects fail? There are some challenges that are unavoidable because they're baked into the technology. So it's non-deterministic. Previously, we mostly wrote our code assuming that it would be deterministic. Of course, we all know there can be things like race conditions, right? There are corner cases, but they're corner cases. We normally write code and we think it does this, 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 and this. With Gen AI, it's inherently non-deterministic. Non-determinism is no longer hiding in corner cases. It's with everything you do. And that's different. Pretty bad, different, unavoidable. We also know about hallucination, which is, I guess, the worst kind of the non-deterministic thing when it does something really bad. We also have certain things that are way more imprecise than we like as computer scientists. For example, the term prompt engineering, which is nothing to do with engineering. Prompt engineering is much more like alchemy. It's like throwing things and, maybe put just a little bit more mercury and eye of newt and I'll get gold out the other end. Very scary, very weird. And obviously it's also slow and expensive to run and scale. So some of these things are largely unavoidable. But we also are very good in the enterprise in making things harder than they should be. It's like part of the definition, I think, of enterprise. So one of the new challenges here is you get a lot of top-down mandates from senior management. We've got to have AI, all the things. Well, you know what? If you don't really have a concrete plan, if you just have an aspiration to follow the latest fashion, probably not going to get great results. So that's definitely a challenge. But it's avoidable. Another avoidable challenge, and this is an interesting one, is you get central AI teams in a silo that own the Gen AI strategy and don't know anything about the business. This is like, the first time I saw this was a large institution in Australia where I was talking to their principal AI engineer. I was explaining in Babel to him. He listened politely. He wasn't that interested because he had no interest in Java. He was a Python guy. And he said, oh, I'll ask around. I'm sure we've got Java somewhere. I've never worked for that organization. I happen to know that of their 7,000 developers, probably about 5,000 are Java. And the entire company essentially runs its critical systems on Java. This person had been in the job for 10 months. And he'd never bothered to ask, what do we build our software on? To which the answer was overwhelmingly Java with some .NET and absolutely no Python. So this is an anti-pattern that I think is fairly common, and it really is a problem. Another avoidable challenge is the greenfield fallacy. So people think that Gen AI exists in isolation, that it's just new, and everything we knew before. No, it's all irrelevant. All of this is new. As Sir John Templeton said, the four most expensive words in the English language are "this time it's different." Usually when you hear "this time it's different," it means people are going to lose a lot of money in the stock market. But it's not different. What we know how to do is still relevant, and we've got to add skills to what we already have rather than ignore the lessons of the past. So, hopefully, you now see and agree this division that I think is critically important between personal assistance and automating business processes. So this means that because we need more predictability to automate business processes, we can't purely rely on things like MCP, right? We can't just throw a whole bunch of tools in an LLM and say, go figure this out. The results will not be sufficiently predictable. MCP is good and important and necessary, but it's far from sufficient. Okay, how do we fix all these problems? The first thing we need to do is we need to attack the elephant in the room, which is non-determinism. LLMs inherently being non-deterministic are problematic for business processes. How do we manage that? Well, firstly, what we do is we break workflows up into multiple steps. Each step has a smaller prompt. It has a smaller number of tools. Prompt engineering is less of a thing because you're looking at this much versus this much. So it's much easier to get predictable results. So that's probably the single most important thing to do. Secondly, ideally, if you need a planning step, you need to do it deterministically. That's one of the areas where I think Embabel has a very important innovation. You also need to work with guardrails to ensure that bad inputs don't corrupt the flow, and you need to emphasize testing, all kinds of testing, as we do in normal applications. Interestingly, with respect to the fundamental division between the idea of, hey, we're on the brink of AGI, let's just give a model tons of tools and a massive prompt and it'll solve everything for us. Since I last gave a variant of this talk, OpenAI launched AgentKit. AgentKit is an orchestration technology. It's very interesting that even OpenAI, Sam Altman isn't quite talking as much about AGI anymore. Even OpenAI are conceding that orchestration is really important. Secondly, you need to get over the greenfield fallacy. Integrate with what works. You know what? If we're going to Gen and AI enable enterprise, we need to embrace the things that enterprise already runs on and make them better. Not pretend they don't exist or that existing assets are in fact legacy. So don't reinvent the wheel, connect easily to existing systems, and leverage existing domain knowledge and coding skills. Essentially do it incrementally. So not this whole idea that it's something new, it's something that can evolve and improve the estate we already have. Thirdly, and this relates to the predictability element, is try not to talk English or German or any other natural language to your LLM. If you can have a more structured interaction where you're asking it to return a structure, where you're potentially exposing structured things in your prompts, you will get more predictable results. And you'll also get much better integration with your existing apps. So if you think about this for a minute, English or any natural language is really hard to work with. The tools for working with English are either really imprecise, like search, they're really expensive, like vector embeddings or actually calling an LLM to ask the LLM to interpret it. They're really slow, they're expensive, they're unpredictable. Whereas if you have structure, if you have, for example, on the JVM, if you have objects, there's a whole lot of things you can do with that, right? You can persist them, you can raise events on field changes, right? You have a much, much richer set of things that you can do with structure versus text. This brings me to a term that I coined a couple of months ago called Domain Integrated Context Engineering. I would encourage you to read my blog on that on Medium. It's this idea that when we work with providing context to LLMs and getting responses back, as far as possible, we should use a real domain model. Even better, we should use the domain model that already exists. So, this comes back to integrating with what we already have that works. And I don't have time to explain it in detail, but I'll probably show a little bit about this in my talk at 3:30. It works amazingly well. Exposing tools, for example, on domain objects, works amazingly well. So if you expose tools on objects, say, that you retrieved with JPA, you can have the LLM, firstly, not seeing the internal state that you don't want to expose to it, and secondly, saving all that context because the tool is being invoked on something that's stateful. So the LLM just knows, for example, to update the customer's address, it can't see anything that the customer has in their data. So this, I think, is a major thing that people are largely missing around Gen AI, and I think Java is brilliantly placed for this. So what can we do as Java developers? By the way, I would say the points that I'm making here largely apply to C#. I don't know personally the framework state in C#, but I would also say that C# is a very important technology for the next phase of Gen AI. So the first thing we could do is we could imitate what's happening in Python. We could look at the Python frameworks like LangChain and we could copy them. We could accept the limitations of those approaches and fundamentally accept that we are downstream of the cool kids, right? That we're not creating anything, we're just imitating. I don't know about you. I wouldn't want to write code if that's the only code I was writing. And I think we can do a lot better than that. So I think we can bring our strengths, look at the fact that enterprise Gen AI isn't working terribly well, and consider the possibility that we're the people who can fix it. So instead of imitating Python frameworks, build something that is better, build something that is innovative, and lead rather than follow. So essentially, enterprise Gen AI is an application development problem. It's not a data science problem. It's not an ML problem. It's an application problem. And we are the people who built those applications and understand how to make them work better. Everything we know about building robust software is still important, and the next phase of the AI revolution won't be Jupyter notebooks. So if we consider Python versus the JVM, firstly, I'm not anti-Python. I'm actually highly fluent in Python. When I, believe it or not, when I came back to Java a couple of years ago, I was way more fluent in Python than in Java. So Python's a really important language. I would encourage anyone who doesn't know it to learn it and become fluent. It's great for data science, great for scripting and prototyping. It is not great for building enterprise applications, which is why there's not many enterprise applications that are built in Python. Data science and Gen AI are very different things. So this brings us to the new framework that I've introduced called Embable, which is a JVM framework for building reliable agents. So what Embable is attempting to do is directly address the causes of failure of Gen AI initiatives in enterprise. And obviously, number one of those things is lack of determinism. So, the core of Embable is aimed at trying to attack non-determinism as far as possible. It's also aimed at integrating easily with existing applications and domain models. Embable is built on Spring, which is probably not entirely surprising, and it's pretty much as easy to add some Gen AI to an existing application with Embable as it is to add an HTTP endpoint with Spring MVC. In fact, in some ways, the programming model has quite a bit of similarity with Spring MVC. It's also designed to allow you to mix operations in code with calls to LLMs very, very easily, which I think is important, and to maximize toolability and testability. So the key innovation in Embable is we have a planning step, but it is deterministic. So there's a couple of approaches. When I mentioned earlier that orchestration is really important. If you want to make your applications predictable, you have to break flows up into individual steps. So there's a bunch of technologies that do this. For example, in Python, two of the really popular ones are LangGraph and CrewAI. So these are different from, say, a LangChain or Spring AI in that these are essentially workflow engines, right? As soon as you get into the space of orchestrating multiple steps, you're in the realm of workflow versus just simply library or traditional framework. So the way in which LangGraph handles this is pretty obvious. You specify your flow in terms of nodes and edges in a finite state machine. Most obvious way to think of it. Before I built in Babel, even before LangGraph existed, I'd actually had 2 cracks at building that in Java before I decided it wasn't a very good idea. Crew AI is kind of essentially you order things in sequence and there's a few nesting things you can do. So both of them are about describing an explicit flow in code. Now that is definitely an advance because now you're making things more predictable, you're breaking things up into bite-sized chunks that you can reason about and evolve much more easily. So definite progress. However, there are some problems. One is that you essentially end up throwing away any ability to type things. Once you're specifying, hooking up your nodes and edges, for example, you've just got to hope that you've got the correct types available at any point in time. Obviously, Python people, for the most part, don't care about that, but in a statically typed language, we tend to care more. Secondly, state machines tend to be quite brittle in terms of things that change frequently. So if you look at some things that are modeled naturally with state machines, like, for example, regular expressions. State machines are beautiful. We all learnt that in computer science. Beautiful for parsing regular expressions. Guess what? Regular expressions don't change very often. So it's not like we have to go and rewire our state machine. Business operations can change, and changing your nodes and edges and rewiring things in a state machine is quite difficult. So Babel takes a completely different approach to planning, where there is a planning phase, but the planning phase is deterministic. It uses a non-Gen AI algorithm called GOAP, or Goal-Oriented Action Planning, which actually came out of the gaming community. It's one of the most common technologies or algorithms for controlling the behavior of non-player characters in games. So even though most enterprise developers have never heard of it, as in fact I hadn't heard of it until I came across it doing some background reading, most of them have probably actually been killed by a GOAP AI at some point, because GOAP is really quite good. So come to my session at 3:30 and we'll explain that more. So Babel is really a server rather than just a framework. So as I said, if you get into the orchestration space, you've got to be managing processes, a little bit different from a traditional framework. One thing that I think is different and genuinely novel about Babel compared to things like LangGraph or Crew AI is the Babel server has a notion of the capabilities that are deployed to it. So as you add more actions and goals, it's capable of doing more things that you hadn't necessarily explicitly programmed. So we have a lot of ambition around this. I would argue that now it's probably already the nicest way to do Gen AI, but I think this can totally develop into the fabric for your enterprise. So you probably can't see the text at the back here. We're very proud of our API. We've put a lot of effort into trying to make it really beautiful. It's a modern API. Most of the framework is written in Kotlin, but most of our users and most of our examples are in Java. So it is really, really beautiful to use from Java. If you think of anything that could make it better to use, please let us know, because that kind of polish on the API layer and making it a joy to use is very, very important. So, compared to Python frameworks, any Java framework is going to have a significant advantage in that it's adjacent to your domain model. So when you think about the adjacencies of doing Gen AI, calling an LLM is pretty easy, right? There's a bunch of work you've got to do to make it portable, like if you're calling OpenAI or Anthropic or Ollama or whatever, there's that portability layer. But fundamentally, it's a pretty simple HTTP call. So that adjacency is not that complex. The adjacency of your Gen AI related logic with your business and your domain model, that's really important. So that's why Java has a big advantage. So this is going to be used in a blog that I'm probably going to get out in the next couple of days. I'm doing a really detailed comparison between Babel and LangGraph. And I think it will become clear that people who think that you have to do Python for Gen AI could be quite shocked. That you can literally take examples that are written with the most popular Python frameworks, and you get less code, much cleaner code, when you put them in Java. So the thoughts I would like to leave you with are that there's a lot of work to be done to make Gen AI enterprise ready, and we in this room are the kind of people who are going to do that work. The JVM is really important. Integration with existing infrastructure, existing domain models is really important. And this is precisely what Embabel is trying to do. And we're very proud of the fact that we're not copying what exists on other platforms. We want to do the best solution, which is, for example, far more strongly typed than any other framework on any platform. So the future is up to you. Build your expertise on Gen AI. I think one thing that I have noticed is that a lot of people in the Java community are not as knowledgeable about Gen AI as they should be. So you don't want to be in the situation where, for example, you're debating a Python person and they know more about Gen AI concepts. It is really important for all of us to do a lot of study, and that is why, as I mentioned, we can no longer just sit in our own little language space. So every developer needs to know multiple languages. Like, I really think, even though I believe very strongly in Java and the JVM, I believe every Java developer should know at least Python, probably TypeScript. We all need to understand the range of things that are out there, and hopefully use Embabel to show your boss that the JVM can leapfrog Python. For example, much of this slide deck was developed with an Embabel agent. So the way it works is the agent spits out Markdown. It's a pretty complex workflow that involves researching topics in parallel and using tools to access the internet. At the end of it, it spits out a Markdown file that's formatted for MARP, M-A-R-P, and then there's a little pipeline that produces the HTML. Another example, that, by the way, is open source under Embabel, is our Tripper travel planner. So this is actually a really pretty powerful travel planner. It's a good example of the comparison with Python stuff because it was inspired by the Crew AI travel planner sample application, and it's so much better. Sophisticated flows, strongly typed, and also really quite useful. So if you're planning a trip, give it a shot, and I think you'll be quite impressed. So hopefully this piqued your interest. To learn more, I have a session at 3:30 today. That is a very different session from this in that there isn't a single slide. It's nothing but code where I'm demonstrating how you can build agents in Java. Thank you.
Thank you so much, Rod. And I really like what you said. This Java community has created and developed with such a strong engineering culture on top of such a strong platform. And yes, get the Gen AI thing and make it happen. Use the opportunity and combine it, right, with the skills and virtues you're already having. Thank you so much.
Thank you.
Yeah, cool. All right.